Hello everyone, this is lecture 7 and this lecture is about solid state fermentation. So far the fermentation process have been discussed are done in using liquid media, but uh, but it is not the only kind of fermentation. Okay, so there are different types of fermentation and one type is solid state fermentation. It is named so because in this fermentation process the microbes they grow on the surface of the solid materials without the presence of free liquid, and this kind of fermentation are occur in the absence or near absence of free water. Okay, and various natural raw materials are used as carbon source in this kind of fermentation, such as barley, wheat bran, rice bran, uh, okay, like sugarcane packages, various oil cake, fruit pulps, coffee husk pulp, etc. Okay, and in this kind of fermentations, all kind of microbes can be used, like algae, bacteria, or fungi. However, the fungi, especially the mycelia forming fungi, they grow most abundantly on solid surfaces. So, using this kind of, using mycelia forming fungi, they offers the greatest possibilities for solid state fermentation. Okay, and uh, I mean, although the solid state fermentation they occur in the absence or near absence of free water, but still the microbes they need water too for their growth. Okay, so in that case the growth is the water is supplied as absorbed state or in complex with the solid matrix. Okay, and the aim of solid state fermentation is to bring cultivated fungi or bacteria in tight contact with the insoluble substrate and to achieve the highest nutrient concentration from the substrate for fermentation. Okay, well, there are basically two types of SSF systems. Okay, two types of SSF systems have been distinguished depending on the type of solid phase used. Okay, so one involve cultivation on natural material. This is the most common SSF. Okay, where the microbes are used are cultivated on natural material. Okay, and there is another type which is less frequently used is on an inert support impregnated with liquid medium. Okay, so these are the two types of SSF based on the type of solid phase. Okay, anyway, solid state fermentation process can also be classified based on whether the seed culture for fermentation is pure or mixed. Okay, so sometimes for some fermentation a individual strain, a single type of strain are used for substrate usually, for the fermentation, and for some fermentation not a pure strain, rather a mixed culture. A mixed culture means where different strains of microbes are present. Okay, so mixed culture can also be used for SSF. Okay, well, solid state fermentation has some advantages and also disadvantages. So first, advantages: the process is a simple process and a cost effective process. uh, Usually less effluent is released, and a product yield is usually high, and a lower chance of contamination due to low moisture level. Ease of product separation is energy efficient, resemble natural habitat of some fungi or bacteria, because uh, I mean uh, sometimes the fungi they are used for solidated fermentation. Actually the fermentation process conditions they resemble or they are same like their natural habitat. Okay, and then allows the development of fully differentiated structures, which is critical in some cases to product fermentation. Okay, So these are the advantages of solid state fermentation, but it also has some disadvantages. Okay, such as heat transfer is a problem in case of solid state fermentation. I mean, whenever fermentation occurs, okay, the microbes they do metabolism. Okay, metabolism produce heats. Okay, and in case of solid state fermentation, controlling the heat is sometimes very difficult. Okay, because there is no cooling system there, that is the which are used in case of liquid fermenter. Okay, so there is no such cooling facilities. Also, agitation is difficult. Okay, and in most, I mean, in some solid state fermentation, agitation is done. Okay, but not as vigorously like the liquid fermenter. Okay, so as because of this, controlling the heat is very difficult. And another thing is, the raw materials which are used in solid state fermentation, usually their thermal conductivity is low. Okay, so that means the heat produced during the fermentation, they get released or removed from that place very slowly. Okay, so the temperature of the fermentation can really go very high. Okay, and if the temperature goes very high, it can affect the yield. I mean, it can damage the product itself. Okay, and also at very high temperature, it can affect the growth of the microbes. Okay. Okay, and another disadvantage is, for large fermentation mash volumes, it can be difficult to provide sufficient mixing because agitation is difficult. Okay, and if we want to agitate it, I mean, agitation is difficult, but theoretically we can do agitation, right? We can if we just speed up the we can if we speed up the agitation. Okay, theoretically we can do it, but the problem will be if we use mycelial cells for the fermentation, they can easily get damaged. Okay, which will affect the yield and cell growth. Okay, now the major factors that need to be considered for solid state fermentation. Okay, so number one, selection of microorganisms. This is one of the key factors for improved yields of the product. Okay, so I mean, which microbes we are going to use for the fermentation. Okay, or bacteria, yeast, filamentous fungi, all can be used. However, the filamentous fungi, they show better results growing on the solid substrate. Okay, okay, then substrate. So which kind of substrate we'll use? So substrate also plays important role in determining the growth of microorganisms. Okay, thereby increasing the product yield. So substrate is chosen such a way that it should provide physical support as well as nutrients to the growing culture. Okay. Then process optimization. Okay, the process parameters need to be optimized. Okay, so the process optimization includes the optimization of different physicochemical and biochemical parameters. So, and these parameters are such as the size, the initial moisture content, the pH, pre-treatment of the substrate, relative humidity, temperature of incubation, agitation and adhesion, age and size of the inoculum, nutrient supplementation. Okay, sometimes like extra supplement for nitrogen, phosphorus, and trace elements need to be added in the fermenter, during the fermentation process. And then a supplementation of additional carbon source and inducer, extraction of product and its purification. So all these parameters need to be optimized to achieve maximum yield. Okay, okay, so That's all about the solid state fermentation. Thank you for your patience.